Good evening, and thanks for inviting me to come down for the day and present. I've recently started a new job, so the first thing I said to my boss was, "Oh, by the way, I'm going to Belgium on Monday. I won't be back until Tuesday lunchtime." So it's great to be down here to be able to present sessions. This first session I'm going to present is kind of a bit of the history and the story, and looking at the background of the Global Render Lab. So I'm going to be talking about the codes, talking about the ideas that went into the lab, talk about how the demo went on the day, some of the concerns that I had, some of the worries that I had, and especially missing out a lot of sleep and stuff, but actually running the lab. It was great fun to do. Just out of interest, how many people attended the Windows Azure Bootcamp? Great, good to see that a few of you there, so you'll know sort of what this demo is talking about. The next session, I'll basically run this for an hour, then we'll take a 15-minute break. The next session I'll be looking at working with social identity providers and the Windows Azure Access Control Service and the Windows Identity Foundation and all that type of stuff, and basically how we can do integration that way. But I'll save that one for after the break. If you do need to contact me or do want to contact me, at Alan Smith on Twitter, cloudcast.net@gmail.com is my community email address, and geekswithblogs.net/asmith is where I blog. So I started out my life in IT, my IT career in 1995, working with ray traced animation. Now, this isn't the kind of sort of ray traced images that I was creating. I was doing, sort of CD-ROMs for kids to learn science and physics. So I was doing like lunar eclipse, solar eclipse, planets, and that type of thing in text-based ray tracers. Ray tracing is an interesting technology to be involved with. It takes a massive amount of compute power to produce ray traced images. For every pixel on the image, you've got to do hundreds, sometimes thousands of calculations to figure out where the objects are in the scene, if there's any light sources in the scene, if they're going to be reflecting light. You can have shiny surfaces, you can have glass surfaces, and it calculates all of the refraction and stuff using some quite complex maths. It's very popular to do this in a text-based way in sort of the early to mid-90s. It's a technique that's used for Hollywood films. So to render, I think Toy Story was the first sort of feature-length film that was rendered. But when they're actually rendering it and producing these Hollywood films, it takes a long time to actually produce these animations. The Croods took something like 9,200 years of actual render time to produce a movie, generated 250 terabytes of data. For big studios to do this type of rendering and produce these types of images, they've already got these render farms set up. But for small companies, they want to produce an animation, and then maybe for a week or for a few days, they want to have massive computing power to be able to produce that animation. But they can't afford to purchase it. They just want to use it for a few hours. So when I was working in the 90s with a ray tracer, I always wanted to create an animation, which was one of these desktop toys, Inboard Animations. But I've never really had the compute resources to be able to do that. That's an image that was created during the render lab. So, Ray Tracing 101, working with text-based ray tracers. You describe a scene where you've got a viewpoint, which is where the camera is. You specify the resolution, the aspect ratio, where the camera is in 3D space, where it's pointing at the camera handle. Specify a couple of lights, and then start specifying objects. You typically work with primitives, so it's disks, spheres, toroids, cylinders, boxes, and so on. And if you put that scene into a text-based ray tracer, a few minutes later, you'll get this type of image coming out. Now, I used C# to actually generate this pinboard image. So I basically got a couple of 4 next loops generating the positions of the pins. And I think there's about 11 or 12,000 pins in that pinboard. Now, if we take a bitmap and we use the bitmap to specify the position of the pins in the pinboard, the actual Z coordinates, you can get quite nice images by projecting out the Azure logo into the pins. What I really wanted to do, though, was to actually take a proper depth image, a depth animation, and be able to actually animate sort of real depth data onto the pinboard. So I used a Connect sensor. I started out using an Xbox Connect, regular Xbox Connect with a Connect SDK, then moved on to using a Windows Connect, which I've got on the amplifier over there. And I'm selecting quite a narrow depth range from the entire Connect ranges field. So I have like a minimum and a maximum depth range that I use to actually generate the pins in the pinboard. So that's my daughter and I taken with the Connect depth camera sensor. It's different to a regular photo image. The lighter the actual object, my daughter's 400 millimeters size, that's closest to the camera. the darker the object is, the further away they are from the camera. So taking that type of image, you can then project it onto the pinboard and get some quite nice effects with actual proper shapes coming out onto the pinboard. Now, ray tracing takes a long time. This is rendering a single frame of animation. We're running at 1280 by 720 so high definition resolution, taking 267 seconds to do that actual single frame. And these are all the calculations that take place. So to do an animation that's going to be 2,000 frames, if you've only got one processor core, it's going to take almost a week to do that animation. So back to the companies, and this really I'm talking about rendering frames in animation. You could be talking about any scenario where you need to have a lot of compute power to perform a task, and you're going to be using it for a short period of time. If you start to build that on-premise and you assume the cost of $500 per blade or per node or per server, per processor, however you think, to run up to a farm with 1,000 instances, it's going to be costing you $500,000. You probably need a room this size to actually put them in. You'd need special power, special cooling, you'd need special networks, you need to put in a raised floor. So it would cost a lot of money to set something like that up on premise. And it's a permanent thing, it's a long-term investment. If you look at the options for working with the cloud to do a 10,000-hour compute job, it's going to be costing you if you're paying, and I think the prices have dropped now. If you're paying 12 cents per hour, it's going to be costing you about $1,200 to do that job. Now that's irrespective of how many nodes you generate. If you built your system and got your architecture right, it doesn't matter whether you spin up 1 node or 10 nodes, 100 nodes or 1,000 nodes. You're going to be getting the job performed much quicker, but the cost is still going to be the same. So for small companies who want to produce the animation or do their compute results, and they want to get quick results, a quick result on their job, the best option that they can do is to work with a large number of deployments, work with them for a short period of time. Maybe spinning up 1,000 nodes in a cloud computing platform, just running it overnight for 10 hours. And it's going to cost the same as running a lot of fewer instances for a longer time period. So the first time I demonstrated this, I really wanted to have a demo that could show the scalability of Windows Azure. I've been to so many presentations where people will show PowerPoint slides about how you can scale Windows Azure or a cloud computing platform. Sometimes they'll talk about a case study where a company has generated a solution that uses 1,000 nodes, but they weren't actually showing the demos really live on stage. So I started off in Gothenburg, I think, in 2010, just building this simple demo where I had 16 worker roles spinning up on my Windows Azure MSDN account. I ran them for an hour to render a 2,000 frame animation. And I used to joke and basically call it the $2 demo because 16 times 12 cents is about $1.96. Add in a few cents for the storage use, and it's about $2 to run that demo. I scaled up that demo, or scaled out that demo, last year sometime by running up to 256 nodes. Because of my programming, the next logical number after 16 is 256. And I had got a special Azure account from Microsoft where I could actually spin up 256 instances. And I've run that demo and done various sort of screencasts and webcasts and done that demo quite a lot. So we're thinking about, where to go from that demo and, where to go next. One of the things that we were talking about at the time was running this Global Windows Azure Bootcamp. Magnus Mortensen and I had basically met in a bar in Stockholm and had a couple of beers and talked about this, idea of doing a boot camp, and then we thought of inviting Martin and inviting Andy in London to actually run a boot camp on the same day. And we had a couple more beers, and the ideas just got bigger and bigger, and we ended up thinking about emailing a lot of people, and we kind of thought we'd have 10 user groups around the world running this event on the same day. One of the things we wanted to do was we wanted to have some kind of lab or some kind of exercise that every event could participate in, and they could share the results. It would be like an actual project. Now the render lab that I've been doing previously, I've done this on my Windows Azure training course. So what I do is I divide the actual course into two halves, and basically have two teams where they're basically deploying these worker roles, and they actually have to do a bit of coding and deploy the worker role and get the worker role running. And you can see on the projector I've got this real-time thing that shows these statistics of all the actual roles. And I says, well, I can just take that lab that I do on my Azure course, I can package it up and simplify it, and we can basically use that. But instead of the 2 teams on the course and 16 people in the classroom, we can scale it up to these 10 events running globally with maybe 500 attendees and so on. And then the event was a bit more popular than we originally imagined. We ended up getting it to sort of 96 locations with about 7,500 people who'd actually registered to take the event. And I was getting quite worried because, I thought, well, it's going to scale easily to 500 users. That's not going to be a problem. It should be fine. But when we started seeing these numbers, we started to panic. So we actually contacted Microsoft and said, we're planning on, spinning up the worst case scenario, the highest level we could get would be 30,000 worker roles spinning up in provisioning in one data center. Is this going to be a problem? And Microsoft basically came back and says, no, don't worry about it. It won't be a problem. We can handle that. Are you sure? It's 30,000, not 3,000. And we were kind of amazed that, they didn't see this as an issue. We kind of thought that they would, be trying to put the brakes on it or saying, think about this, is this sane? Is this going to work? Is this going to make everybody look bad and fail on the day? So I started programming. One of the things I actually added with this sort of sharks with freaking lasers thing that's been going on with the Windows Azure on Facebook, I actually added this as a feature, and it was cool to write this code for each shark with freaking laser on its head in the sharks with freaking lasers on their heads, shark with freaking laser on its head attack. Well, I basically put this in as an Easter egg in the actual 3D animations, and you will see that appearing in some of the animations. Another thing I did was, added different lighting effects, different ways that the camera can move. I put in like a disco lighting effect, a normal lighting effect. I was also going to put in a spooky lighting effect and a rave lighting effect. You can see that the actual code there isn't implemented. I didn't get a chance to implement those effects. So a bit about the technology that I'm using. I use the worker roles to actually host the rendering process. I'm using heavily Windows Azure storage. I make heavy use of blobs for storing the animation frames, the scene frames, the completed animations, and so on. I make heavy use of queues to actually distribute the load between those. I use Azure Table Storage a bit, but I've actually moved stuff across to Windows Azure SQL database. And I'll talk about the reasons for doing that a bit later on. I use Windows Azure Media Services, which is going to be taking the actual animations that are created and then producing them into an MP4 format using the Media Services encoding, and then making the actual video available. So when you actually play the video on the website, that content is actually coming from Windows Azure Media Services. And I use Windows Azure websites to actually host the website for the actual lab. So when you go to the renderlab.azurewebsites.net, that's the actual Windows Azure website I'm using. So a bit about the process. We use the Connect application to take a series of depth frame animations, typically between 200 and 500 of these animations. These are then uploaded into blob storage in Windows Azure. Once these are uploaded, I put a message on the queue and say, okay, create this animation. And there's three processes running within the worker, or three different tasks it can do. The first one is creating the animation, where it basically takes these depth images. And from these depth images, we generate the text files for the actual ray tracer. So with 500 of these actual depth frames, it will generate 500 text files, one for each frame of the animation. It will also place 500 messages on the render queue, each one for a single frame of the animation. The render job processing is converting the actual the scene description files into JPEG files, and each JPEG file is a single frame in the animation. So when you see the frame counts on the actual website, these are what we're talking about, how many actual frames we've rendered. And this takes anywhere between 5 and 10 minutes, depending on the complexity of the frame, the number of objects that are in the frame. Again, these go into blob storage, the actual completed frames. Now, when the last frame is complete, we put an animation, an actual encoding message on the queue. And this can kick off the encoding process, and that's going to download all of the frames, produce an AVI file using virtual.exe. The AVI file is then published to media services, and then we put in the job into Windows Azure Media Services and say, okay, convert this actual AVI file into an MPEG-4 file so it can be viewed on the website. So monitoring was a big challenge for me. When I'm sort of running my own deployment, you're basically in charge of that deployment. You have control of it. So you can deploy something, you can scale it up to 256 instances, and you can delete that deployment. First challenge I had was, how can I monitor everybody's worker role that's running globally? How can I also have some control over these actual worker roles that are running. My biggest nightmare was, something goes wrong with the deployment package and I need to release a new version. I can't contact everybody who's in the entire bootcamp and tell them to undelete and redeploy a new version. The people in Australia will probably be sleeping, and they may have worker roles running. So I'll talk a bit about how I've implemented that. Also, monitoring. I want to monitor the role life cycles. For the actual scoreboard, I want to know, how long the worker roles have been running, who's got worker roles running in different locations, the number of frames that we've been rendering, what the render time was, when the worker role started and when the worker role stopped. And if you took part in the render lab, you entered your location, your country, and your user details, and they're basically stored in the database. So I've got some kind of information about the worker role cycles. So as for monitoring events and errors, when we start an animation, when we complete an animation, any errors and exceptions that occur, I want to be able to see those. And I use a console application to basically read from queues. So the monitoring, I'm using Entity Framework, and there's a role lifecycle table there. That's basically what that model looks like. That's what I'm storing in the database. For each animation job, I've got another table in the database which is storing information about the actual animations. And this, I'm basically using the queues for the errors and the events. So I've got my on-premise where I can actually monitor this, the actual on-premise application. So this is basically what the actual queuing looks like. I basically have this method called log. I basically log this. If it's an error, it goes on the error queue. If it's just a regular event, it will go on the events queue. And I've encapsulated the actual queuing logic. I'm using the transient fault handling exception block here to actually enqueue the queue messages. So we'll do a retry if we can't actually write to the queue. Okay, let's have a look at see how this application works. I'm just going to go into Studio and just run the capture application. So I'm doing Control F5, and this is basically running a simple Windows Presentation Foundation application, which is hooked up to the Connect sensor. Now, setting the depth, I can basically opt to choose a near mode if I want to, and I can set the maximum and minimum depth here. So if I basically set a depth, something like this, I can then start the animation, do my dance in front of the Connect, and then basically stop the animation. Now, what's being displayed here? A lot of the challenge on the actual lab was communicating to people how to use this device. This is kind of a histogram here where I can retune the maximum and the minimum depth, and it's kind of hard to see this on the actual projector. But what I want to do is basically select this peak here in the animation. That's going to be my animation, which is 141 frames long. I can basically select that lights are going to be disco, the camera is going to be still, and the action is going to be kung fu, and this will be Alan Test. And then I can just click on upload. And what I'm doing is basically firing off a separate process here, which is actually a C# console application that's doing the upload. The reason that I did this is earlier on I had some stability issues with connecting this device here. So if this application exits, then I've still got my upload application running. And you can run these concurrently, and they can take a long time. You can be uploading whilst you're still recording other animations. So if you look in storage, this is going to be placing all of these actual depth images on the actual blob storage, on the depth image blob storage. And eventually, when it completes, it will basically place a queue onto the actual animation queue. And that will basically kick off the entire process. So onto the actual project itself. This is the Azure project, and I'm going to basically run a deploy here. So the first challenge I had was, how do I knock off other people's worker roles? And one of the things that I did was I basically got in this table here the version. Now I've set the version in the table to 2013-0506. That's basically the version that we're running with. In the actual worker role itself, at the top of workerrole.cs, I've got this actual deploy version, which is set to 2013-0506. Now, when the worker role starts up, the first thing it does in the actual run method is basically goes and gets the actual version from the actual storage. And if the version doesn't match the actual build version, then it basically kills. So during the testing phases, when I needed to release a new version, I could just update that version in the actual storage. All of the running worker roles just basically went into an idle state. And it does this every time before it actually dequeues a message. So I could turn off, if there's 10,000 instances running, I can just switch them off immediately by changing the actual version. It just basically sits here doing this, thread.sleep and updating the database just to say it's still alive. Okay, so it should be good to deploy my package. I'm going to basically package this up. and run this and deploy this to Azure. So I've got a few Azure services. Let's just pick one that's running in the North Europe data center. So let's take this one here, upload a production deployment. So I'll take that package that I've just deployed. I think my configuration file says just run with one instance, so I'll just make that selection now. Now the updater has completed, so if I go into my depth image storage and look at the animation jobs queue, let's just do a refresh. You can see that I've got a new message. If I look in the message here, it's just a simple pipe delimited message here that basically says the number of frames in the animation and the various modes that it's going to use for the animation. So that will be dequeued when my worker role spins up. So monitoring the actual application, I basically use a console application. So this test console here, if I do a Control F5 on this, it gives me the option of whether I want to monitor the logs or the queues or the actual errors. So let's just choose the logs. And there's currently nothing running in the queue. Now, when my worker roles start running, we will see information being displayed in that actual console there. So during the 26 hours that the actual lab was running, I was pretty much glued to this console application, watching what was happening and also using the errors one to actually look at the errors and exceptions that were coming out. That's how I was basically looking how the lab was going. Another thing I put in that I was really wanted to do was the option of having a kill switch, and a kill switch for different countries and different regions and different individual servers. So if we go back to that table and just do a query on here, you can see that I've got this which is called hit list. Now hit list, I can put in a pipe delimited list of countries. So I could put in USA, pipe Canada. Every worker role, it basically, as well as checking the version, it will check if the worker role is on that hit list. So it checks the country, it checks the actual location, it checks the employee email, and it also can do it against the actual server name of the actual server that the actual instance is running on. Now I had to use that because when I was running the testing, I released a test version, then I released, okay, this is the final version, and released it. And somebody in the US spun up 40 instances on Friday afternoon, and it got to like midnight on Friday, and I basically launched the actual lab, and I says, okay, I'm going to launch the lab, and I'm going to reset all the scores. And this guy in America wasn't happy. He's saying, well, I've just had 40 instances running, I've got all of these frames rendered. I says, yeah, but you're really in the test phase, and we don't want America appearing like the top of the actual scorecard. We want to give Australia a chance to come on. So I actually used the hit list to kill, I think it was America and Brazil, who actually had instances running, and basically reset their actual scores to zero. So Australia could come on and start actually competing. But the reason there is, if somebody at some location figured out how to take the package apart and modify it so their score just went up, I could disable it. If I saw through my exceptions console that one worker role was causing all sorts of problems, I could disable that individual worker role just through the actual console. So I wanted to have some control over what was going on in the actual deployment itself. Okay. So during the testing phases, we started to get a few exceptions. The first exception was related to, and these are basically showing the exceptions I was getting on my error handling console. I was also writing out the actual server name, which is RD, which stands for Red Dog. That's the actual server name in Windows Azure. Then the country, the location, and the actual name of the actual user that was generating that exception. And the first one was there is not enough space on the disk. I'm using local storage in these worker roles to actually render the frames and compile the animations. Now, when I was doing my 256 instances demo, I only ran it for 60 minutes. So we never actually, used up the actual space on the worker, the actual local storage. I never had to delete any files. When we had the instances running for several days, as we did during the test phase, we did start to get the actual drive spinning up. And putting in code to actually delete the actual work once we produced the animation or uploaded it, then delete the animation or delete the frames that we've already rendered. I put in that code, and that basically cleaned up that problem. But again, this is something that I only came across when we were actually running the testing. A bit absent-minded of me to not implement that, but there you go. The next one was the system cannot find the drive specified. I'm using the couple of actual executable processes to actually render the frames. I'm using polyray.exe and I'm also using virtual DOB. And I had hard coded something like e:/approot, I think. Is it, Martin? Yeah, as being the actual place where these were located, because when I tested it was always e:/approve. Now, apparently, if you update your deployment, the drive that you're using for your actual application root, the actual second virtual drive, will change to the F drive. And that's basically why I was getting these, the system cannot find the drive specified. And it's Martin that actually helped me to figure this one out. I just basically put in some code to actually get from the local environment where the actual runtime drive is, and that basically cured that exception. The next one was a bit more mysterious, and I haven't actually diagnosed this one yet. This happened Wednesday lunchtime. I was getting lots of issues with the worker roles getting failed connections when connecting to Azure Storage to be able to read data. I thought it could have been throttling. As we were running in the test, we had a few hundred instances running in test, and we were getting these exceptions. And this was looking like being a showstopper for the whole lab. Basically, I had, I think it was 4 options. The first option was to cancel the lab completely and not do the rendering lab. The second option was to run with the rendering lab as is and just basically say, okay, well, there is a chance that it won't work because of this issue that we've got. The third option was to call Martin and tell him to actually move the date of the whole Global Windows Azure Bootcamp forward a week, so I'd actually have time to diagnose this issue. And the last option was basically to actually try and figure out what this problem was and see if I could resolve it. It wasn't due to throttling. I tried very low actual polling in the system, and I still got these exceptions. I tried running on-premise using the Azure Storage emulator. Everything worked fine. I was using the Azure Storage Explorer, like downloading the images. Everything worked fine. I then went across to the putting the storage in the North Europe data center and having the worker roles in West Europe, and everything worked fine. So I moved the worker roles across into North Europe as well, and that worked fine. I tried with the worker roles in North Europe and the storage in West Europe, and I still got those exceptions. So I think it was something related to the sort of a networking infrastructure of worker roles inside data centers contacting the storage in West Europe. I'm not sure if it's still going to be experiencing these exceptions, but for me, that wasn't a show. That could have been a showstopper. It ended up being a sleep stopper. I basically got this finished and resolved. I think it was on Friday lunchtime. I actually decided that we could actually go ahead with a lab, and it was working as expected there. But yeah, it kind of was a bit scary for a while when I was thinking that was going to be an issue. One thing I implemented during that work when I was trying to improve the reliability was using the transient fault handling application block. I'd run the 256 cores demo probably about 10 or 20 times and tested it probably 10 or 20 times, and I'd never hit any exceptions with storage. But this is just a sample of code. If you are working with Azure Storage or SQL Azure, or you're working with a Windows Azure Service Bus, this transient fault exception handling block is going to be useful to have. It has, I've not dug into the code too much, but it has this storage transient error detection strategy, where I think it basically looks at the exception that is being thrown when you're trying to access storage, and it will decide if you can actually do a retry on that. So I'm just guessing here, but I would guess that if your key and your name don't match, or you can't actually log on to storage, there's no point in retrying, and it won't do a retry there. However, if it gets something like the previous exception, where it's an actual timeout exception, it will say, we can retry this set, we'll go on and do a retry. So that you basically put the code in here, you want to run blob.download to file, here's the actual file, and it's basically wrapped inside this retry policy.execute action here. And that's basically all you need to do. If you want some kind of feedback every time a retry is happening, you can see I'm using this basically generating this string here. Then I'm using log.message. I'm actually writing to the actual log file when this has happened. So I see in my counter when these actual transient retries are running. I think during the entire 26 hours of the Global Render Lab, I think I only saw that actual retry get executed once. So it was pretty stable running in Windows Azure. So that's basically sort of quick and dirty coding that I did to actually basically get that to work. I'm not sure if it's the optimal implementation, but I used it and it worked for me. So on the day, Saturday, 27th of April, when we did actually start to kick off the actual global render lab, I was really nervous because this thing, it was either it could be the highlight of the whole Global Windows Azure Bootcamp. If it doesn't work, then I'm going to look bad, Microsoft's going to look bad, Windows Azure is going to look bad, and that's going to happen in front of a global audience of all the people attending this actual bootcamp. So a lot of people would have seen it fail if it would have failed. The other thing was testing. We can't test it. There's no way I could actually do this simulation from a technical perspective of having that much instances running, but also from the actual how people run this, how people read the instructions, how people actually work processing and uploading the animations. I had no idea how many people were going to take part in the lab, how many instances we were going to get running. So it's very exciting to do. It was challenging, it was a bit frustrating, but it was really rewarding to see everybody get into the lab and start working with it. Those events that did. So this is the actual screenshot I took from the website at the end of the session. Towards the end, we had 3,846 worker roles still running. The total worker role instances was 9,793 around. I think it went up to 99 something. I'm a bit disappointed we didn't get into over 10,000 there. It would have been nice to see 10,000. And that means that this basically counts if somebody in Australia started 5 instances and ran them for 6 hours and then deleted their instances at the end. That would count as 6 of these actual life cycles here. So that's how many worker roles we run. This is the running worker role instances, is how many are actually running and active and processing these animations. We processed 724,000 frames of animation during the actual render lab. Now, there wasn't 700,000 generated by the attendees. I basically generated a lot of background frames where there was some kind of prioritization with the queues, and I'll talk about that a bit later on. So a lot of this work was basically background work rather than the frames of the actual animation. This is the total render time, 1,644 days, with the actual total worker roll time of being about 2,000 days. So you can see the efficiency here of how long the worker rolls were running compared with how much time the actual worker rolls spent rendering frames. So this is probably about 5 years or something like that. Yeah. 4 or 5 years of actual render time that we managed to get between us just during a 26-hour period. The top locations here. Good to see that Belgium here was, running really strongly in this lab. I think Berlin overtook them. I haven't really looked at the statistics of how many people they had there, but they were really going for it as well. Sweden, unfortunately, was a bit off the bottom. We had quite a small event, but quite a few people did take part in this. It was really interesting to see people competing in this. We didn't take the competition too seriously in Sweden, but I've heard that in Belgium people are really going for it, and it was interesting to see that actual information coming up there. Top 10 countries. Sweden did make it onto the actual top 10, and this is basically mostly the Stockholm location. There was a few people running the event in Gothenburg. Other interesting things to note is if we actually look in the website at all the actual countries. If I go into the all countries section, we had Ghana competing. There wasn't a global Windows Azure Bootcamp in Ghana, but Ghana basically appeared here as an actual country, so I added that flag to it. And we got all kinds of weird countries like United States of America spelled like this, and then United States spelled like this, and then East US, and then we got Middle Earth appearing in Europe. One frame. If you look at the old locations. We see Middle Earth's actual locations where it's quote semicolon 1 equals 1 quote or 1 equals 1 dash dash. So maybe trying some SQL injection attacks. Luckily, I was using Entity Framework on there, so those didn't get anywhere near the actual database. But I had challenges with doing these flags for these various countries because if the country isn't spelled correctly according to the actual list, although I made the instructions quite explicit, then it basically doesn't appear with a flag, basically because these are hard-coded with the actual flag names and so on. It's good to see sort of how many people were actually competing in this. So what I didn't actually explicitly say, and what I really should have done in the uploader application, is basically show the photo that it's taken with Connect, and have a button saying, do you want to upload this photo and publish it on the web? Because a lot of people basically have these photos going, and they have no idea what was going to be actually shown on the web there. I was kind of thinking, I hope nobody just gets out of the shower and then, let's just test this application on Connect and just uploads it and realises it's been published on the net without them actually knowing it's taken this photo. So these are actually taken with the colour camera in Connect. There's basically a depth camera as well as a colour camera and a microphone array, and these are coming from the actual colour camera. So this is basically what happened. Friday night was a long night for me. I think it was about 1:45 when we saw the first actual worker role being deployed in Australia, and the actual lab was running. And that's when I killed all the US instances and deleted the actual test data. I stayed up until 4 o'clock in the morning to actually make sure that the lab was running, and we'd had by that time 256 instances running. I then went to sleep, and my daughter woke me up at 7 o'clock in the morning. First thing I did was checked and saw that the lab was still running smoothly. Went in to start the event in Stockholm that was starting at 10 o'clock. By 10:30 we had 1,000 instances running, 11:30 2,000, by 1 o'clock it was 3,000, 1 o'clock. Oh. Yeah, I got the time. That must have been 2 o'clock because it's UTC time in the actual time log that I was looking at. So that will be 1400 Swedish time. We were up to the 4,000 instances. We sort of peaked and level off. I think at one time we had 4,700 or something. That was the actual maximum. 2 o'clock in the morning was basically when it was the end of the render lab, and I basically stayed up so I could actually kill the instances and basically freeze the actual scores as they were, and prevent USA from rendering even more frames of the work because they had a lot of instances running. I finally got some sleep at 3 o'clock, and my daughter woke me up again at 6 o'clock. So basically, I think, and bearing in mind that previously I was working on those transient error issues with Azure storage, so I didn't get too much sleep on Wednesday night or Thursday night prior to that as well. So it was a lot of work to actually pull this thing off, but it's fun to see it working. So this is basically the data that I've extrapolated from the database. I'm basically saving into Windows Azure SQL database the start time and the end time of the actual role life cycles. And from that, I can basically run through a query and basically download the data set and say for every minute how many actual worker roles we're running here. So you can see this was basically when the lab started, and I've basically discounted all of the test data when there's 200 roles running in America for testing purposes. And this is basically when Australia kicks off here. And then we got, I think, India coming in here, and then it got to Europe starting. I think this was some of the more eastern countries in Europe. I think it was a couple of events in Romania that started off. And this was when Belgium and Germany and Sweden came in, and it really jumped up. And then we got the US events coming in and really pushing up the scale up there. So according to this, we were just under 4,500 worker role instances running continuously. And then as the events started running and firing off, it basically got down to here. So I checked on the actual statistics. I can actually go in, and what I've been doing is basically trying to get people to stop running instances here. So if I run this query here, I think I may need to connect. I'm basically selecting all of the running instances that we've got in the actual render farm. So there's currently 88 worker roles still running. I was basically emailing and putting messages out on Twitter, and I basically can also select the discrete email, select distinct email from these guys that are still running, and sending out BCC emails from Gmail and saying, just stop running our instances and so on. I got an email from one guy who was saying, I went to use Windows Azure on Monday, and all of the actual my Azure account was disabled because of the Azure compute time had been used up. It says, and then I contacted Microsoft, and they had no idea what I was talking about. So I emailed them a link to your blog post to explain, why my Azure account has been disabled. So I hope I'm not going to be getting any sort of feedback from Microsoft regarding this. But really, it's the attendees' responsibility. It's the organisers' responsibility. We've checked there aren't any still running from Belgium, but there should be this one actually running from. The actual instance that I deployed. So what you can see, this is what I was seeing on my console application when I'm monitoring. You can see it's starting instance RD00155D. This is the actual server name of the actual server in the data center. Sweden, Stockholm, Alan Smith. So I know that I've started my instance. Animating complete. I've basically got the actual job being complete. So it has done the first job of taking the depth images and generating the frames, and now it's actually started rendering the frames in the animation. And you can see I didn't have the actual frame rendering message turned on when I was running the lab. There would have been 2,000 too many with those 700,000 of them. You can see each frame, you can see how many seconds it's taken to render this frame. I did have this turned on during debugging testing. So with the scalability, if I go into the actual scaling section and scale my instance up to 6 instances here and click on save, we should see, roughly I'm doing this at pretty much 10 past exactly, we should see how many minutes it takes for the actual scalability to come in and those extra instances to scale off. We won't see the completed animation by the end of this first session, but maybe by the end of the evening we will see the completed animation if I'm running these 6 instances here. So this is what I'm doing with storage. My first concern when I was thinking about how many instances we could have running was how many transactions I'm going to be running against Windows Azure storage. Because there is a limit, I think, Martin, is it 5,000 transactions per second that you can run against a storage account? Something like that.
Yeah, or 500 per partition.
Yeah. So, I could have been hitting issues whereby I'm just running too many transactions against storage and I'm going to be throttling. Now, I thought of different ways of solving this. One thing I thought of doing was generating 10 storage accounts and using round-robin load balancing across those 10 storage accounts. That would have worked. It would have been quite complex to implement. The other thing I thought of doing was partitioning across multiple storage accounts and having, this is what I did, I have one for the actual depth images. So the Connect controller is uploading to depth images, animation jobs, and it's putting its photo in the photos block. Then when we actually produce the animation, we put the scene files here and the actual queues into the render job queue. So this is going to be the queue that's taking a lot of the actual workload. Then I've got a separate storage account for encoding here with the frames, the encode jobs, and also the queues for the events and the errors. And then Media Services has its own storage account that I'm using for all of the media files. And that's the video. And that seemed to work fine for the actual lab. This is the actual usage graph from the Windows Azure portal of the actual storage. Now, I did not go in and check these during the day. I should have done because it would have made a really interesting tweak pick to actually tweak this during the actual lab. So this is basically the peak load. If we go back and look at the load here, you can see that this graph sort of matches this graph here. So the peak here was basically over 2 million requests per hour on the actual queue storage. So that works out about 585 requests per second against the actual storage queue there. And we got no throttling issues that I detected, no actual retries, no transient errors. I don't know how close to the actual threshold we were getting on that, if we were getting anywhere near to the actual threshold. If we'd have had double the amount of instances, if things would have been started to fall over. But I think it's really cool to see how this is actually scaling and the amount of load that we can just place on a single Azure storage queue. Oh, there's a beep there. One thing that I am doing here is I'm actually using console.beep. I don't know if anybody's used that for years and years and years, since the 80s probably. But I basically use that so, when I was doing the testing, this thing would start beeping and I'd just run away across the living room and see what was happening. You can see here that we're starting another instance here. Now, it was, I think, about 2.5 to 3 minutes ago that I actually selected to scale that. And now we're getting the new instances appearing and actually starting up on the actual console. So it's quite responsive now to actually do the scaling. It would have been interesting to see, and I didn't monitor this or ask anybody this, what the actual provisioning time was when everybody was really scaling up this. I kind of thought that you'd ask to scale to 20 instances and that would take an hour because there's thousands of other people already asking to scale up to that number of instances as well. And I thought that would maybe cause some issues. But I didn't put anything in that would be able to actually monitor or verify that. So it looks like we've got the other 5 instances starting, and that's only taken sort of 3-4 minutes to actually scale up. And that's quite running quite quickly. The lower graph, this is the blob operations. So we're on about 400,000 blob operations per hour on the actual storage at that present moment in time. The RenderLab website is running on Windows Azure website, so I kind of think that people talk about scenarios as to when you would use a cloud computing scenario for running a website, and this is really displaying it perfectly. The Friday when we were doing the testing on the Thursday and the Friday, we got 47 web hits on the Thursday. We got 874 on the Friday when we were actually doing the testing. During the day when we were running the lab, we got basically 40,000, just over 40,000 actual page requests. Not that many unique visits. It was kind of the same people pressing F5 and pressing refresh, watching the actual stats change. But a lot of actual, web requests during that particular day. I basically took that snapshot just after midnight, so there's only one request on there at the actual Sunday. But we got about 2,000 requests on Sunday, 1,000 requests on the Monday, and now the actual graph has really petered off on that website. Not many people are visiting at all. And this is coming from Stats Counter. This is coming from Google Analytics and showing the actual peak through the day of when we were getting the most number of actual page views. So it's almost up to 6,000 page views an hour there, which is roughly 100 a minute or something like that. Maybe, yeah. So, about 100 minutes. So, this website was just basically running on one reserved instance in Windows Azure websites. I didn't get any issues with that. What I'm doing is I'm actually caching the data for about 1 minute, about 60 seconds. One thing I was concerned about was the load that I'd be placing on Windows Azure SQL database. Because when I actually bring out those statistics queries, I'm doing a lot of selecting everything from a big table and doing all of this group by and selecting the sum and all type of stuff, and ordering by the actual country, ordering by the region, ordering by the number of frames rendered. So I was concerned that running so many queries against Windows Azure SQL database was going to start generating issues with the actual database, which would affect the worker roles actually writing to the database and cause problems with the worker role. So I put in the caching, which really limited the amount of actual load that we're placing on the Windows Azure SQL database. So onto media services. This is what Windows Azure Media Services was doing during the day. The purple line is the encoded data in, which is showing how much data per hour we're actually sending in the AVI files. Now, I could have done more research on this, but I was basically using virtual DOB, and I was using quite an inefficient compression algorithm to actually compress the videos. Basically, the codecs, the compression algorithms that virtual DOB uses have to be installed on the machine. So when you spin up an instance, it's Windows Server 2012, it doesn't have that many video codecs on it. So that means that it's kind of limited in how you can actually compile the AVI files. So the AVI files are quite big. So I was sending in a lot of data. That's 6.57 gigabytes per hour. And this is how much data was coming out. These are not to scale, so it's doing quite good compression on these videos. This line in orange is the actual queue depth of the queue for Windows Azure Media Services. So that's basically built on Azure, and it's got a queuing system. So if you send 100 videos into Windows Azure Media Services, they won't be produced immediately. They'll basically be placed on the queue, and it will render, when I tested it, about 10 videos at once. It will actually go through the actual rendering process, and then they will appear sometime later on the video. Now, again, I wasn't watching this during the lab, and this went up to 43 actual animations at its highest peak, which means that your animation, if you'd recorded an animation, you could be waiting, I think it was sometimes an hour and a half, the actual animations come out on the website, which isn't good. I could have actually scaled this. I was just running on regular on-demand capacity. I could have scaled this to have some reserved instances, and that would have basically reduced the actual queue depth here. Again, this is something that I really should have been monitoring in order to get the animations produced more quickly during the day. So a couple of things that I really want to focus on doing in future versions if we decide to do the Global Windows Azure Bootcamp again, and also if we decide to do the RenderLab again. Again, it's kind of a list of sort of my wish list for stuff I should have done if I had time. So one thing that we didn't do, which I felt was a bit of a shame, was to make more effort to publicise the lab. When I was in Turkey with Magnus and Active Solution, we met the guy who was running the event in Turkey, and he didn't even know that we were going to be actually running this RenderLab. And so, Turkey didn't take place. Japan, we actually met the guys at the MVP Summit who were running the Global Windows Azure Bootcamp in Tokyo. We couldn't understand a word that they were saying, and they couldn't understand a word that we were saying, so we couldn't actually communicate. But they were really keen to run this actual event, and through maybe some kind of language barrier, they hadn't taken part in the lab either. Also, because I had that issues with the reliability of the lab all through Wednesday and Thursday and onto about Friday lunchtime, I didn't even know if the lab was going to go ahead. It was only like Friday lunchtime when I thought, yeah, we can actually go for this. So I wasn't really in the mood to start publicising and blogging and tweeting and emailing people and making sure they were aware of this lab. If I was going to email them 24 hours later and say, forget the render lab, we can't do it, we've got these reliability issues. So we should have been able to do that to make more of that. Animations should be easier to create. Partly my fault when I built the actual Connect application that's capturing the data. I built it as a quick and dirty Windows Presentation Foundation application that I could understand how to use on stage. Looking at the results that people have produced with the lab, some of them didn't really sort of get how the animation creation would work. And if you upload an animation, it takes an hour before you actually see the results of the animation. It's not really giving you quick feedback about how to correct the animation again. So make it easier and focus on being able to do different animation styles. I want to make the... one thing I want is an incentive for locations to create more animations. The render lab was running on sort of background processing jobs that I'd loaded up, like thousands and thousands, hundreds of thousands of frames that were just rendered and not used in an animation. What I think I should have done was focused on having the countries actually rendering their own animation jobs. So if your country wanted to move up the actual table, they had to produce animations as well as actually rendering the animations. So the queuing system, a bit about how that was working. I basically generated a queue for every country. I think I can show you that in the actual storage and the render lab rendering, if you look in the queues. Yeah, so every country has its own queue for render jobs. Now, when I uploaded my job in Sweden, all of the actual messages I'm rendering here get put on this render queue Sweden job. All of the worker roles that are deployed in the country of Sweden, their priority will be to actually dequeue the messages from this render queue Sweden job. So if somebody from Sweden, the challenge that I had was if Australia loaded up thousands of animations, then all we're going to be doing in Europe is rendering the animations that were created in Australia. We'll have to go through all of that work before we get onto our own animations. So that's why I redesigned this quite late on to actually use these based on country. So for Sweden, we'll basically prioritize the Sweden. And then after we do that, then we start going through the other queues and saying, okay, do any other queues have any messages on? So the Swedish instances, if there's nothing here, would start going through the other countries' queues and rendering those frames. Second render jobs, this is where I basically generated my massive bulk load. I put thousands of messages on this second render queue here, which would basically be the ones that will be processing if there are no other render jobs from any of the other countries there. The animation creation should be more reliable. One of the things, and I can show you how this happened in the code and why this happened. If we go into the actual animation and then into the encoder processing, which is this one here. So when I was hitting those reliability issues in Azure Storage, it will be actually sorry in workrel.cs when I dequeue the encode messages, which is going to be down here somewhere. Yeah. So I've modified this. What I'm doing here is basically dequeuing an encode job message. So I dequeue this message. If the I'm actually dequeuing the message here from using the transient fault handling exception block. If the message is not null, if we do have a message, then I actually delete the message. Now, this isn't a great thing to do. This really affects the actual reliability. The reason that I did this was because of the reliability issues I was facing when I was testing. The first thing that the actual job that is going to be encoding the movie does is to download the 500 frames in the animation. And when I was hitting this this reliability thing, it was sometimes taking over an hour to actually download all of the frames in the animation. Now that would mean that if I hadn't set a really, really long timeout on this, then the actual encoding message would become visible on the queue because it's invisibility timeout will time out. So another process would start trying to encode the same animation. You get duplicate animations coming up on the actual screen. So that's what I've done. I basically decided as a quick fix to prevent that from happening, just to actually delete the queue message. I should have actually moved that down and basically made it placed it at the bottom so that that wouldn't have happened. Now, the thing that happened that surprised me a bit was the frequency that people were actually downscaling or deleting their deployments. I thought that people would, come to the boot camp, spin up their 6 instances and leave it running all day, then take it down at the end of the day. But sometimes I was getting, 100 worker roles being actually deleted per minute or something per minute. So if one of these worker roles was encoding an animation, if we've read the message, deleted the message, we start doing our encoding and then the worker role gets deleted. That animation is lost and there's no way to recover it. Now, lucky I'm not processing credit card transactions or invoices or so on. We can get away with it in some kind of social lab scenario. But really should have been a bit more reliability put in there, and that could have been done with more time. Look into ways or more variation in the animation style. I kind of felt all the animations were very, very similar. The camera was always rotating in an anti-clockwise direction. It was always the same camera rotation. And I had fooled around with different things where I'd basically flown the camera through the actual pins in the pin board, which looked quite impressive. But I just didn't have time to implement those. Another thing is look into leveraging more of the Connect features. So you can actually do green screening in Connect, where you stand in front of the Connect and it combines the depth image with the actual color camera image. So you could actually have yourself actually in the actual animation with an animated background, which would have been quite fun to do. Also, if it's possible, use the skeleton modeling in Connect. So you can actually capture your skeleton, and then you could create, some kind of like animated droid or monster or something that would be actually in the animation, basically doing the same moves that you were doing whilst you were being captured. That would have been fun to do, but it's just a question of time. So before the session signs off, I can just show you, I think, a couple of the actual prototypes that I had in the actual animation test. If I can find these. So that was a different effect. This is basically my daughter, and what I was doing there was basically doing a mirror effect, where I was using the depth data to basically create a height field here in this mirror. So it was a mirror, but the actual person who was being animated would basically be a peer being projected out of this mirror. I was thinking of doing stuff like that. That would have been nice, but I really got hit by the reliability issues when I was actually working with the rendering. So it's a real shame that I couldn't get that. Another thing I tried doing was doing like the Abyss, where I was basically modeling water, and it's kind of like a water pool where the actual person's face was coming out in the water. And I tested it. I don't know if I've still got a few of those frames available. I might be able to show you them after the break. I don't want to do them up now. But that was taking, I think, about 6 hours to render each individual frame. The actual model of the water was so complex within the ray tracer. So that would have succeeded in slowing down the actual number of frames rendered, and it would have been nice to do. But I kind of thought that 6 hours was a bit excessive compared with about 10 minutes for rendering those individual frames. What I was working on previously a couple of days ago was, let's see if I can find that here. So I kind of wanted to have this thing where it was like the Matrix, where instead of lots of guns, we needed lots of servers. So I basically did that as an animation to actually animate inside a Windows Azure data center. And this is where I was thinking about doing the green screening, where you can actually take the people and put them actually inside the data center and all the servers come down. And the one I was actually doing on the plane that I didn't manage to get finished was this one here, where I've basically started animating the racks, and you can see the lights flashing on the actual router there. I haven't actually managed to complete the animation there. So basically doing it in ray tracing now. This is really a sort of a proof of concept here. I've actually got somewhere I've got a PowerPoint slide which I don't really have access to do, but what I'm doing is creating these actual depth images here in PowerPoint showing the actual blades, and this one is showing the actual router there, the actual details. And these are basically projected and layered on top of the actual boxes that we've got. And then I've basically modelled the LEDs that are flashing on and off. And I think there was over 1 million LEDs in that actual animation of the actual server and like that. And they all flash on and off. They're all basically modelled like that. I'm using C# to actually generate the actual images there. And you can see the actual size. These are basically the scene description files. If I just open this with a notepad. I should have turned on performance so you can actually see the amount of memory. This is basically a scene description file for just one of those scenes. And that's basically holding page down. You can see the scroll counter going there. And most of these are just the LEDs that are flashing on and off on the actual terminals there. It's fun with the actual C# to be able to generate these ray traced images and just send them into the actual ray tracer and get the images out. It can handle these millions and millions of polygons and so on. Okay, so that's it, 7:30. I say break for 15 minutes. I will be around to take questions, and then 7:45, I'll go into the session on working with the social identity providers and using access control service. Thanks.